Applications of sine rule and cosine rule in triangles. For any triangle ABC, prove that b square minus c square into cot A plus c square minus a square into cot B plus a square minus b square equal to cot C equal to 0. Here we have three terms in the LHS. And those three terms, if you observe, we can notice they are cyclic changes of the previous one. What does it mean? You may change A to B, B into C, then C into A. That is, change A, B, B, C cycle. Changing A to B, B to C, then C to A. If you do that here in the first term, you obtain the second term. Here again do the same. Change A to B, B to C, and C to A. So there are three cyclic terms. So exactly what would happen to one term will be repeated, will be similarly reflected in the other two terms also. So what I am going to do here is I will just go on simplifying one term in detail. Then its result will be just reflected in the second and the third one. Just because the three terms here are cyclic terms. Let me go ahead simplifying the first one. First term only I am taking. B square minus C square into cot A. B and C, small b and small c, we can write as K sin B and K sin C using sine rule. So B square minus C square will be K square sin square B minus K square sin square C into cos A by sin A is cot A. Here let me take K square common. K square taken common. Sin square B minus sin square C into cos A by sin A. Similar thing will be done here also. K square taken common. Here sin square B C minus sin square A. Same thing here. Taking K square common, we are here. Now, sin square B minus sin square C, we have a formula. Sin square A minus sin square B equal to sin A plus B into sin A minus B. Using that formula, we can say it is K square into sin B plus C into sin B minus C. And this cos A by sin A is continuing. Let's complete its simplification now. That is, look, here there is a B plus C. And we know we are doing the question in a triangle ABC. Since it is in triangle ABC, angle A plus angle B plus angle C will be pi. So angle B plus C will be pi minus C. Angle B plus C is pi minus A because A plus B plus C is equal to pi. Rest all copied as it is. Now what is sin pi minus A? Sin pi minus A is sin A. So K square into sin A into sin B minus C into cos A by sin A, you can cancel this sin A and sin A. And what are we left with? K square into sin B minus C into cos A. Let's now change this A again back to pi minus B plus C. Pi minus B plus C. Again because A plus B plus C equal to pi. Now, what is cos pi minus theta? It is minus cos theta. So we may write minus K square sin B minus C into cos B plus C. This is a product of sine and cos terms. We have formula to convert the product into sum. Sin A into cos B is half of sin A plus B plus sin A minus B. Here A plus B, A is B minus C and B is B plus C. So while adding them we have sin B minus C plus B plus C is 2B. B minus C subtract B plus C is minus 2C. Half of. Then comes minus K square into Sine 2b minus sine 2c, because sine minus 2c is minus sine 2c. Now, the first term we completely simplified. The same thing would have happened to this. Only thing is, the angles involved are C and A. So this would have come down to be minus k square by 2 sine 2c minus sine 2a. Let me write that directly. As I told you, these are cyclic expressions. So the third one would have been minus k square by 2 into sine 2a minus sine 2b. Here. This is it. Now it's complete. We may write all these terms simplified also. These two terms also. For time being, I am going ahead with them. Let me take minus k square by 2 common. I am left with sin 2b minus sin 2c plus sin 2c minus sin 2a plus sin 2a minus sin 2b. 6 terms. Oh, have a look. Minus sin 2a is there and plus sin 2a is cancelled. Minus sin 2b and plus sin 2b 0. Minus sin 2c plus sin 2c 0. The whole bracket is now 0. So the RHS 0 is obtained. Again, I am telling you, it's not a complete proof. We would have written the second term and the third term simplifications also. It would have gone like this.